Welcome. In this final section, we're looking at Helm, a crucial tool in the Kubernetes ecosystem. We will cover what it is, how it works, and often conclude with a summary of the key object management principle we discussed. What is Helm? So what exactly is Helm? You think of it as a templating engine and a package manager for Kubernetes manifests, all around into one. At its core, Helm allows you to create a template of YAML files with placeholder. At runtime, it replaces this placeholder with actual value that you define. This artifact that Helm produces is called a chart. A chart essentially is a bundle of all manifests that make up your application resources. This chart file can be uploaded to a package repository, much like you do with the Docker image or npm packages, making it easy to share and reuse. The Helm ecosystem offers a vast public repository pre-built reusable chart for common applications like Grafana and Postgre, which you can save a huge amount of time. Here is the standard Helm chart structure. A Helm chart must follow a predefined directory structure. You can name the root directory anything you like. So as you can see here, I have the tree of my current chart. Inside this directory, two files are essential: chart YAML. These files contain metadata about the chart, such as its name and version. Value YAML. This file holds the key value pair that will be used anytime to replace the placeholder in your template. All of your Kubernetes manifest template must be placed inside of the template directory. These files can have any name. The chart YAML file. Let's look closer to the chart YAML file. This file describes the chart at its high level. The mandatory attributes are API version name and version. There are many optional attributes you can provide. Later in the demo, I will show you the content of the chart YAML. Next is the value file. This file defines a default key value pair that are available to be injected in your template. If you don't want to replace any value at any time, this file can be completely empty. The template file. Finally, we have a template file, which must live in a template directory. A template file is just regular Kubernetes YAML manifest that can optionally contain placeholder. Placeholder are defined using double curly braces. To reference a value from your value YAML file, you will use expression, double braces, value, and the key. Executing Helm commands. The Helm executable offer a wide range of commands, but two of the most fundamental are Helm create and Helm template. The Helm create command generate a starter, a blueprint chart. For example, I use it to create my own chart named Amazing Chart. The Helm template command render your chart template locally and output the fully processed YAML to the console. This is a great way to inspect and validate your manifest before deploying them. So let's switch to the terminal. So what I'm gonna do now is using Helm create, and then I'm using my amazing chart as a name. So here I'm creating an amazing chart using Helm create. It created a local directory here named amazing chart. As you can see, I have this value here. One is chart YAML, another one is value.yaml. As we discussed earlier in the presentation, we have file here, chart YAML, which contain the information about our current chart. So let me show you the chart YAML. Here, the mandatory things are version and the API version. So the name is amazing chart and the version is 101. It's follow the semantic versioning, as you can see here. So you can use this standard to version your application. The next thing is template. So template contain all YAML manifests that we want to define. In our case, we want to deploy application with ingress resources, with the deployment. So I'm printing the deployment. And here you can see a lot of placeholder following the standard of placeholder curly braces, and then value from the value file and replica count here. So the next thing is to changing the replica count. So I'll show you later in the demo when I'm replacing this value. Once you're happy with your render template, you will want to bundle them into a distributed chart archive file. This is done with the Helm package command. The chart archive is a compressed tar file with a tar.gz ending. The package command used to metadata from the chart YAML to name the archive file. So let me do it here under my current amazing chart. So as you can see, it created the chart and they made amazing chart 01 tar.gz. This is the version after the name of my chart. This is the tar.gz file is a self-contained Helm chart artifact that you can share, version, and deploy. For a full list of command and workflow, the official Helm documentation is always the best reference. When it comes to storing, sharing, and retrieving the chart, there are several common options, and the most typical approach is to push the charts to the chart repository. To do that, you need a chart repository endpoint that Helm can authenticate to. Here are the main options for the hosting and obtaining the Helm chart. OCR registries, recommended for modern workflows. Helm now supports storing chart in OCI compatible registries such as GitHub Container Registry, GitLab Container Registry, Amazon ECR, Azure Container Registry, Google Artifact Registry, and so on. So command for pushing to the chart is something like this. So let me switch back to the terminal so you can see how we push the chart into the repository. So first you need to authenticate to the OCR repository, same as like Docker login. You will log in into the repository with Helm login, and then you can push your own chart into this repository. I don't have any repository at the moment, so I'm skipping this part. But this is a way to push the chart into the repository. Another another command is helm pull the version on OCI. Well, basically it's the same as Helm repo update, but you will get the actual chart and the tar.gz file directly from the repository. Then you can access to this Helm without installing it. So you can get the actual template files. Traditional Helm chart repositories. These repositories are served as index.yaml, and Helm can fetch chart or HTTP and HTTPS, like Chart Museum, GitHub Pages, JFrog, Nexus repository, or it can be like simple HTTP server or so the command is helm repo add myrepoexample.com. For example, here's something like this. And then you can push your own chart into the repo, something like this. Or you can also create your own a simple HTTP server and use Helm repo index and then name here, and it will create an index dot YAML for you. This is essential for Helm to fetch the information about the current existing version of YAML or version of charts in your repository. So whenever Helm send a request, it's looking for the index.yaml in your HTTP server. And if it finds the name, like the amazing chart, it will try to fetch this information from your repository. So this is another way. So it's basically very flexible for you to how to push and how to fetch the charts from the repository. And the last thing is to using the local repositories, something like this. So you can use your own repo and adding your local repository from your local file system. This is useful when you are using something like NFS share in your organization, and you're sharing the charts using NFS among your machines, and you're not allowed to connect to any. But this is very basic. So I recommend you to use actual repositories like JFrog to host your own repository in your self-hosted location, basically. Helm supports a wide range of options, and it's not possible to cover every use cases. However, the most common operation include creating a chart, installing a chart, upgrading a release, and uninstalling a release. For example, let's have a chart called Amazing Chart, and I want to change the replica count. You can test these changes using the following command. So what I'm going to use is helm template dash dash set replica count 2. And as you can see, it's generate the YAML manifest for me for all resources. And then I can use grep to see the replica counts. Here the replica count is 2. Let me change the replica to something like 10 and see what's happened. As you can see, replicas changed to the 10. So this is the beauty of using the set and placeholder in the manifest. Another way to changing the variable is to feeding the template with a new YAML file as a values. So we have the values. I'm getting this into like new values, new value, and then now I'm changing the new values. Like I'm changing replica to something like 5. This is more like deterministic. This is more easy readable and easy to track. Basically good for GitOps. So you can always track your changes in the values. Now to read the values from the newly created new values YAML file using -f, and then it will create the new manifest for us. And now we can get the value. So it was a replica, and now we should see that the replica is 5. We can also change again the new value to something like whatever we want, like 6. And then check again. As you can see, the replica changed it to the 6. So this is the flexibility of the Helm. So we can play always with the values. So the next topic is Helmfile. Managing a production-ready Kubernetes cluster often involves installing and coordinating multiple Helm charts. A convenient way to handle this complexity is by using Helmfile, which let you define dependencies between chart, control installation order, and maintain consistent deployment. This becomes especially useful when one chart relies on another. For example, when setting up TLS, Nginx ingress depending on cert manager. Below is example of Helm file that installs cert manager first and then Nginx ingress afterward. Here under the YAML manifest directory, I have this Helm file directory, and here I have the Helm file. So this is the structure of our Helm file, which include repositories, releases, and the values that we are using for our chart. Basically, I mentioned the version. So here there is a version for Nginx, and there's a version for cert manager. Comparing to the Helm that individually we need to Helm install, then release, and then repo, the Helm file is much easier. We are using Helm file and then apply. This will check the actual difference between our current Helm file and what we have in the cluster. Let me change the Helm file and change some values. So ingress at the moment I have 2 replicas for my cert manager. Let's change it to the 3 replica. So instead of 2 replica, it will expand the 3 replica. So to get the actual current pods dash and cert manager, we can see that right now we have 2 replicas for our cert manager. Let's see what happens if we use the Helm file apply. As you can see, it detects the difference between the current release and what we have in our cluster. So this will change the replicas from 2 to 3 replicas. And it applied the changes. So right now, let's get the difference. And as you can see, it's spinning the new replicas for me. And the most important thing here that I use this need option to make a cross dependency between the Nginx and cert manager. So before installing the Nginx, it makes sure that the cert manager installed in our cluster. And I'm using install crd true for cert manager to make sure that it also install the crd files, because Helm automatically is not installing the crd. So this is important to having this option. So now we have a running manager in our cluster and Nginx ingress to serve the request. Thank you for watching. I'll see you in next topic.